So the first guy is like if I'm doing number 8, you've got 3 to the 2x equals 27. So the first thing you want to do when you've got x's up in the exponent is to try to write both sides with the same base. And here we can do it. I know 27 is 3 to the third. So if 3 to the 2x equals 3 to the third, if the bases are the same, the exponents have to be the same, and you just solve. If we did a more interesting one, if I skip down to number 12, that's not even that interesting, but that's okay, we'll do it anyway. Equals 81. Again, we can write 81 as 3 to the fourth. So if the bases are the same, the exponents had better be the same, and then you just solve what baby equation comes out of there. No big deal. They didn't try to do anything weird. Like this one has 1 over 125. So 125 is 5 to the third, and since it's 1 over 125, it's 5 to the negative third. So now the bases are the same. So you can set the exponents the same. We've got them. And that's what's going on there. Sometimes we have to be a little bit careful to distribute. They love the space of 3. My God. So 27 is 3 to the third. So if that's to the 2x, if you've got powers to powers, you can multiply those powers. So that's 3 to the 6x. And then if the bases are the same, the powers are the same, and then you just solve that. Yeah. All right. But then we get to number 16, and we have 4 to the x equals 19, and we're like, I can't write 19 as 4 to something. Sadness. So then we get to use logs. Yay! So I'm going to take the log of both sides. Log of this side will equal the log of that side. And then I'm going to use my properties I just learned to pop that x down to the front. So now I have x times the log of 4 equals the log of 19. And the log of 4 is just a number. You could pop that in on your calculator and it would give you like 0.6. So if you had x times log 4, you basically have 0.6 times x, or x times 0.6. And if you were solving this, you would divide both sides by 0.6 in a heartbeat, right? And you would get x, oh, that's a number too, and you would get x is whatever the log of 19 divided by 0.6 is, right? Here we're going to keep it in its exact form, and we're just going to divide by the log of 4. So x is going to be log 19 over log 4. And then if you wanted to, you could pop that in on a calculator and get some sort of decimal approximation. But that's it.
The entire thing?
Kinda. Yeah. Let's see what else they do to you. So if you were doing something like 18, you would try to get this 3 to the x alone. So you would subtract the 5 from both sides. And then you would divide both sides by a negative. And then you would try to write 45 as 3 to some power. But that's sadness. Can't do it. So you do the same trick we did last time. You take the log of both sides, because the logs are the opposite of exponents. And then that'll bring that x down to the front. And then you'll divide both sides by the log of 3. And you'll have x equals the log of 45 divided by the log of 3. And you'll leave it there. So exciting. Yep. They can get a little longer if I were to do number 22. So again, I try to write them with the same base, but I can't write 5 with a base of 2. It's just so sad. But logs come to the rescue. We take the log of both sides. And we get to pop this whole thing down to the front. It comes down as a big chunk, 3x minus 4 times the log of 2 equals the log of 5. So now remember, log of 2 is just a number. I don't know what it is. 0.3. So if you were solving 3x minus 4 times 0.3 equaling the log of 5, wouldn't you distribute that 0.3?
Mm-hmm.
Yeah. We're going to distribute the log. It's going to look a little chunky, but you're just going to do it.
So you do the log with the 2.
So the log of 2 is like 0.6. It's a number, right? So we're going to do 3x times 0.6 or 3x times the log of 2, and we're going to keep it in that exact form. And then when I do 4 times the log of 2, I'm just going to keep it as 4 times the log of 2. That good?
Mm-hmm.
And so once you have that, like this would be, because the logs look scary, but you just kind of have to remember that they are numbers. If you were doing this one, you would add 1.2 to both sides, right?
Mm-hmm.
So when we're doing this one, we want to get this x alone on this side. This piece doesn't have an x, so we're going to add 4 log 2 to both sides. And so you're going to get 3x log 2. And on the other side, you're going to have log of 5 plus 4 log 2. Last step to get that x alone, the x is being multiplied by both the 3 and the log of 2. So you're going to divide both sides by both 3 and log 2. And you're going to pop, and that's going to cancel, that's going to cancel. Give you x equals this whole mess on the right side, just like so. If you wanted to pop it in on your calculator, you could put parentheses around the entire top and parentheses around the entire bottom and punch them in all at once. Or you could do the top and the bottom separate and divide. I kind of like doing it all at once, but be sure you don't just type it in without parentheses or something like that. And then you'll get something. And that's that.
Okay.